What's going on, y'all? It's Daniel Litwin, the voice of B2B, and welcome to another episode of the Rugged Edge Survival Guide, a Premio podcast. You're joining us here for a Rugged Edge Survival Guide webinar limited series. So if you missed our intro episode with Director of Product Marketing Dustin C2, you're going to want to make sure you go check that out, right? We set the whole stage and prime you for the breakdown that we're going to be getting into today as we explore Premio's product offering. So again, I recommend that you all go check that out before we dig in today. But if you're all caught up, then great, welcome back. And on this series of the Rugged Edge Survival Guide, we're going to be exploring at large, but in a more practical fashion, the evolution of the edge computing continuum, right? As edge computing is maturing as a sector, and as its use cases become more established in their respective industries, so too are the products maturing, right? The edge computers themselves that are powering different user edges and their use cases. So what we're doing with this webinar series is we're contextualizing that evolution of the edge continuum and that definition of these user edges around Premio's product suite, right? We're going to dive into Premio's product suite and figure out how each product and set of products align with some of these specific trends that are shaping the edge continuum, the edge computing market, and again, the various edge user types, right, that are maturing in the market today. So today, we're going to be breaking down the Premio BCO series of flexible and reliable edge computers for industrial IoT applications, and we're going to be breaking it all down today with Mr. Colin Wu. He's on the product marketing team for Premio. Colin, welcome. How you doing today?
Doing well, Daniel. Thank you for having me. I'm excited to kind of be on here, just really kind of share what we have in store, especially for our BCO series. I'm ready to kind of just dive right in, kind of show what the series is all about.
Absolutely, man. Thank you again. And again, folks, I recommend if you want to get that bigger picture overview of the evolution of the edge continuum, the maturation of the market, and how that's defining different user edges, make sure you check out our previous episode of this limited series here with Dustin. Okay, so as sort of a recap of that first conversation with Dustin, Colin, could you recap kind of how these user edges are maturing at large, right? What are some of the high-level trends that are pushing edge computers to align closer with some of the specific use cases that they're now being deployed for? Just give us that quick summary again of the main trends at play here.
Yeah, I mean, a lot of what kind of Dustin talked about really is kind of highlighting that overall growth and kind of what you see from the edge and how they're kind of shaping and how they're growing. So you have a lot of the key trends and key things that are really pushing edge computing deployments and applications to kind of like the next level, specifically starting with, obviously artificial intelligence, machine learning. And that kind of really just drives really what we see happening at the rugged edge. A lot of application deployments are going to become a lot more smarter, a lot more automated. And that really kind of all ties into, the next step, which is where is that kind of processing happening? It's through that compute technology. So edge AI and semiconductor technology is also even growing faster and faster to kind of compensate for that whole growth of machine learning and edge computing through artificial intelligence and machine learning. And in addition to that, obviously, you have this whole convergence between IT and OT, for information technology, really kind of combining it together with operational technology to really kind of push and drive digital transformation for Industry 4.0 applications. And really, a lot of that all comes down together with another one, which is that connectivity, network flexibility at the edge. So 5G, 4G, LTE, wireless, Wi-Fi, 6E, and even Bluetooth. All these things all kind of combine together to really kind of drive this whole growth and drive the trends that we're seeing right now at the rugged edge.
All right, well, now we're going to contextualize that trend again around a specific Premio product suite, right? Today, we're going to be looking at just the BCO series. So I think it's important first to just define what the BCO series is in terms of types of rugged edge computers and really what the mission of the BCO series is compared to others, right? What are its main goals? How do they at large fit into some of the evolutions in the edge continuum that we're seeing across the industrial, rugged, and specialized edges? Give us that overview of the BCO series.
Our BCO series is kind of our brand new x86 semi-rugged industrial computer line. We really kind of push this out because it's kind of helping us to further define our position within the edge continuum. So yeah, as this kind of Dustin mentioned before, between industrial edge, rugged edge, and specialized edge, we see that within each section, there are specific criteria or specific demands that people have in those certain areas. Where in industrial edge, you have, like you mentioned, we have some controlled environments. You have, flexible performances. People are a lot more able to kind of implement certain types of computer applications within their solutions. Whereas the rugged edge, you have very, very harsh and extreme environments. You have certain areas that really, really need something to withstand harsh environments. So our BCO series kind of falls really within the industrial edge, where it's semi-rugged industrial computers. It's very flexible, very reliable for industrial automation, industrial IoT solutions. But it still offers very, very robust reliability because it's still able to meet the demands that people have at the industrial edge or even within that edge continuum.
So in the previous episode, or this kind of starter episode of this series, we established the edge continuum like matrix here, right? To visualize where all of these edge computers sit along the different user edges, as well as understanding them on a scale of cost to functionality. Could you go ahead and place the BCO series on that matrix for us to better visualize their roles and just kind of further break down their purpose in the larger edge computing ecosystem?
Yeah, of course. So in that matrix, we kind of split it up into the industrial edge, the rugged edge, and specialized. And from what you see on that kind of matrix, you have, overall cost going from the center all the way to, higher cost, and TOPS performance, TFOS performance from low performance all the way to high performance. And the BCO series really sits, linearly in that industrial edge, with the BCO 1000 really kind of at that, center point between very low power, but and low and TOPS performance. And as you kind of scale up from the 1000 to the 3000 and all the way even up to the 6000, you're going to have that linear scalability of, performance and overall cost, because as you scale up, as you go up in size, you're going to have a little bit more ability to retrofit some sort of acceleration or even just higher performance efficiency.
All right, so I think the best thing to do now is break down each BCO product to better understand how it fits into these specific user edges. So let's go ahead and start with the first one, which is the BCO 1000 series. It's a fanless mini computer. So I think it's best if you just give us the full breakdown here of its core functionality and, again, where it fits into these specific user edges, and then we'll get more specific with some follow-ups.
Yeah, of course. So it's just kind of to kick us off, obviously, our BCO 1000. It really is our ultra compact, semi-rugged industrial fanless mini computer. It's going to be extremely small in size and really kind of built around that small form factor to really kind of push into IoT gateway applications, or even anything that's going to be space constrained. A lot of what you see in the BCO 1000 is really kind of there to kind of be a counter partner to our super rugged line, which is the RCO series that a lot of people are very maybe familiar with. But our BCO is going to be not as ruggedized, not as giving all the bells and whistles with expansion and everything, but it's there to offer everything that a customer or OEM system integrator is going to need, from rich IoT centric connectivity, or even just like the Intel Alder Lake and performance on that chip, and all the way down to its industrial grade design. It's still, although we say semi-rugged, although we say it's not going to be extremely ruggedized, but it's still able to have that robust built rugged, built ready that we kind of really like to pride ourselves on. So it still has a very wide operating temperature, has that shock and vibration resistance, it has that wide power input to really still survive and really to bring that reliability at the rugged edge, specifically in that industrial edge area that we really kind of bring up, where it's a lot of controlled environments, or even just a place where a OEM integrator is able to access the BCO 1000. It's not super far away, it's not super remote. So having that ability for everything that you see on the computer to be present, and therefore is integrator, is kind of one of the biggest things that the BCO 1000 brings to the table. There's not any need for further additions that further ability to add on anything else like you see with the RCO. But a lot of what people kind of see is exactly what they need right there. So providing them with exactly what they need is kind of what the bread and butter of the BCO 1000 or even the BCO series overall is able to kind of bring to the table.
One of the most important aspects of the BCO 1000 is its size and its fanless design. Can you break down why a fanless design is important, or what benefits it brings to the edge computing environments where the BCO 1000 is going to operate, as well as why its compact size can help, enhance its deployment, or, what benefits that brings to the table as well?
So yeah, when we talk about fanless, it really is a key design concept that our industrial computers really utilize, because it removes a lot of the error points that you can potentially see when it comes to implementing industrial computers at the rugged edge. Within this edge continuum, within the industrial edge, within the rugged edge, even the specialized edge, there's going to be what we talk about when we always say harsh environments. So there's going to be things that could potentially interfere and cause a lot of errors or even potential shutdowns of the computer. And by being fanless, remove a lot of those error points, because you don't have active cooling fans, you don't have vents that could potentially bring in dust or debris, you don't have cables that could potentially cause some sort of issues or anything like that. So being fanless really prevents any of those errors from happening. So in addition to also being fanless and removing a lot of the active cooling vents or cables, it allows the BCO series, it allows the industrial computer overall to kind of have a much more low power efficiency. You're not outputting a lot of overall wattage from the computer itself, so it's still able to run very, very efficiently, very effectively, without outputting a lot of power consumption or even siphoning away a lot of the power, which in a lot of these environments, in a lot of rugged edge environments, you're going to see that power is a very, very big kind of like demand, or even kind of like a very weary kind of thing that other people are looking at, because they don't necessarily have that stability with power at the edge.
Now, from a connectivity and integration standpoint, the BCO 1000 really makes an effort to establish itself as a reliable foundation for a lot of the different networked needs where it's going to come into play, right? For example, the inclusion of Wi-Fi 6, Bluetooth 5, optional 4G LTE, right? All this is meant to improve its connectivity in industrial IoT applications. Can you break down why it's important to have that spread of different connectivity types, and how that's meant to kind of insulate and help bake it into existing as well as future use cases for industrial IoT?
Yeah, so the rich IoT connectivity, from just even its input, output, or IO that we have on board, all the way down to its wireless connectivity, it covers a very, very wide range. So for the BCO 1000 specifically, you have a wide range of IO ranging from its USB, its display out, and even serial legacy COM ports. Just by having all that on board, it really allows the customer or even any of the integrators to really see like, hey, we're able to cover you from all your new IoT devices, or even down to the legacy analog ones. And a lot of people are still using COM ports or analog IO. So it's able to kind of really retrofit perfectly in with a lot of different types of IoT devices. And then additionally, with the Wi-Fi 6, with the Bluetooth, that allows you to have that wireless connectivity, which is kind of a key thing that we talked about before, with the whole trends and everything. Having that connectivity is so important, because being able to not only communicate and send data and process that data, wirelessly, or even through some sort of wired connection, it's one of the key and most important things for a lot of these new applications at the edge today, because we're seeing, like we talk about that trend where data is not necessarily being generated, through cloud or anything. It's being generated at that specific point in time. So very, very important to, communicate with those IoT devices that are generating the data, and very important for the computer to be able to communicate with them and send, data where it needs to actually go, where it actually needs to be, completely further processed or even, identified more.
And then another critical feature here, the BCO 1000, is its low power consumption, right? This is big. I think a lot of end users are going to appreciate that, especially when we're talking about launching these at scale and, already having to manage concerns around as Industry 4.0 matures, some of the needed, power spend that is going to take to, keep all of these upgraded and interconnected machines and data points active without downtime. So I'm curious if you could detail how that low power consumption fits into some of the major trends you're seeing in Industry 4.0 today and industrial IoT, and why that is an important feature for this user edge.
So that low power consumption, I mean, for us, it's really comes down to the processor, the kind of what we select from the semiconductor. Everything that we pick is going to be, a very low TDP, specifically for the BCO 1000. We use the Intel Alder Lake N97, which kind of operates at a very, at 12 watt TDPs. And it really kind of, like I said before, it really ties back into kind of the overall physical space of where this edge continuum kind of sits and where we sit. Despite whether it's, we say the industrial edge has a little bit more of a controlled environment, it's still going to be harsh. It's still going to have a lot of factors that really dictate how the computer should be operating and how it's supposed to operate. So when it comes to the BCO 1000, that low power consumption, and the fanless design and everything, it kind of all culminates together to really bring further reliability. So, if the BCO 1000 isn't drawing a lot of power, it's able to kind of give a lot of customers more flexibility, more reliability to be like, hey, this is just one piece of the pie. So, and it doesn't, take away from too much of their overall solution. I think that's one of the most important things that they're going to be looking for, especially for a kind of ultra compact fanless mini computer.
And if you had to think through some of the core use cases where you imagine the BCO 1000 is going to be most useful, right? Specific operations or machinery, for example, that will benefit from the BCO 1000. Where do you see it really shine when in action? How do you foresee it's going to continue to play a role in industrial IoT?
Mm-hmm. Yeah, so for our BCO 1000, we really like to say that it kind of is a NUC alternative. So that's kind of one of the key things for the 1000 to kind of really play its role in a lot of times where people are using, very compact, very small size industrial computers, they're doing something with something that's going to be like Intel NUC. And those necessarily aren't always going to be the most reliable or robust or even have that kind of design where it's allowed to really operate and function properly within, the industrial and edge environments. So that's one of the biggest things that we also see. And another application that we kind of see the BCO 1000 really truly shining is, like we mentioned before, IoT gateways. A lot of real-time telematics are going to be happening at a lot of, in a lot of different types of solutions around the industrial edge. And for the BCO 1000 and its IoT connectivity to offer that amount of IO to connect with IoT devices, to connect with all that kind of different types of devices generating data to really communicate, really drive telematics for a lot of solutions, and we really see that kind of being the most real-time use case for a lot of scenarios for the BCO 1000.
All right, Colin, thanks for the breakdown on the 1000. Now let's jump over to the 3K and the 6K. So we're going to break down now the BCO 3000 as well as the BCO 6000. They share a lot of similarities. There are some key differences, but let's go ahead and shine a light on them. So again, the BCO 3000 is a small form factor computer as well, and the BCO 6000 industrial computer, capable of operating in incredibly harsh industrial environments. So let's get more specific. What differentiates the 3000 and the 6000 from the 1000 as well as from the larger suite of industrial edge computers?
So when you make the jump from the BCO 1000 to the 3000, even the 6000, you're going to see a really big increase in performance. From the 1000, we were utilizing that N97 processor that I kind of previously mentioned. And that processor itself is more of a system SoC design where it's built around a single port computer, and then our 1000 uses that single port computer with industrial grade chassis. However, when you go from the 1000 to the 3000, you're no longer using that SBC per type performance. You're moving into a socket type performance with the 3000 and the 6000. So you're able to utilize Intel, core CPUs in a 35 watt TDP. So a little bit more, power demand, but it's still going to be very low TDP design, and still going to be very efficient, very reliable. So just making that jump from the N97 to a socket type performance is going to be the kind of the biggest factor that you're going to see from moving up in that form factor design.
So let's break down more specifics now about the 3000 to start, right? I know it's powered again by the 13th generation Intel Core processors, which make it capable of handling high performance computing tasks. What are some of those computing tasks that the 3000 would be best suited for, and that you already see or expect to see in practice?
Yeah, so I think for the 3000 itself, it's going to be a lot of repeatable automation tasks that you're going to be seeing, that really kind of demand the CPU type performance, or the socket type performance that you see with the 13th generation Intel Core processor. And a lot of what you really see in that processor is really, a lot of how they designed that chip and how they really utilize it to allow for, a lot of different types of automated tasks to kind of consistently happen on a day-to-day basis. And Intel kind of really made a big breakthrough when they kind of developed this generation from 12 and 13 with their P&E cores, that hybrid core architecture that really allows for the cores and the performance to really dictate, like, hey, this is how exactly the workloads are going to function. This is exactly what cores are going to be tackling these automation tasks. So you can, from the performance cores, you're going to see a lot of the heavier workloads being allocated to that. And then on the more multitasking roles, you can see the Intel processor being able to allocate into the efficiency cores. And by doing so, it really allows the BCO 3000 to kind of, shine even more, because it's able to kind of allocate resources properly, and then still provide even higher performance, higher reliability, and in a lot of those solutions that you kind of see.
Another core feature of the 3000 is its wide temperature support, right? Industrial environments can get really hot. They can get pretty chilly too, especially as we get closer and closer to the rugged edge. Even though we're really talking about the industrial edge, even within some of these controlled industrial environments, those temperature ranges can vary widely, right? So can you break down how the BCO 3000 was designed to maneuver and get deployed in and operate in this wide range of temperatures, and why that makes it ideal for the industrial environments and industrial automation use cases that we see today?
Yeah, so it's just kind of kick us off, you see that fanless design that we kind of always mention, by having, the ability to remove active cooling, it drastically improves its ability to integrate easily within industrial edge environments. From the 3000 and even in the 6000, and what we talked about previously with the 1000, its operating temperature goes from 0 to 50. It has that military standard shock and vibration resistance. It has that wide power input from 9 to 36 VDC. All of them kind of contribute to allow the BCO series and the 3000 and to kind of really operate reliably in that industrial edge environments. And you said that, although we talk about controlled environments, we talk about a little bit more flexibility at the edge in the industrial edge, there's still a lot of demands. There's still a lot of, potentials that you never know could happen. For example, we can talk about a factory floor being part of the industrial edge where there's a lot of, human interaction, or even possible movement, or even, ways for integrators to easily access the 3000 to do, possible routine maintenance, or even just updating and upkeep. But it still doesn't discount that whole factory floor has possibly dirty power. There's a lot of dust and debris that could be happening within that environment. So it's not going to be perfect. It's not, as comfortable as, sitting in an office building, sitting in a data center, where everything is nicely controlled, nicely cooled, so you don't have to worry about those things. But in that environment, for example, the factory floor, it's still going to have demands where a normal computer or a normal desktop workstation isn't going to cut it. So the 3000 design, from that chassis all the way down to that overall operating temperature, power input design, it's able to kind of really withstand that kind of thing. So no matter, even if it gets a little bit hot, it gets a little cold, it's able to reliably operate.
So another kind of upgrade point comparing the 3000 to the 1000 is that the 3000 has more I/O, or input-output port variety, right? Supports LAN, COM, USB, right? These are all essential for diverse industrial applications. Can you contextualize that for us a little bit? Why is that variety so important, especially in the use cases where we see the 3000 deployed today? Break that down for us.
So you mentioned I/O connectivity, so, and then you said USB, LAN ports, COM ports, and I think those are always going to be the essential ones that people are going to be looking for. But obviously we don't know exactly how many they need because every application varies case to case. But for the 3000 to offer the amount that it has on board without the need for any expansion or modularity, so you can see that the 10 USB ports, the 3 LAN, 2.5 gigabit ELAN actually, and the legacy analog ports, it really covers a wide range of different types of applications, that you're going to see in the industrial edge. So for people to have the ability to have a lot of IoT devices that they need to connect to, the 3000 really kind of is able to cover the wide range. So we never really know exactly, what they have, what they need, and how much they need it. But for the 3000 in its small form factor to offer as much as it has on board, really drives home the essential needs for people to be able to kind of connect as many devices as they need to the 3000. And then in terms of applications, like with the 1000, you're going to see a lot of automation tasks. So the 1000 functioning kind of as an IoT gateway. The 3000 is pretty similar in a sense, but it's just really another step up above from the 1000. More ability for devices to really communicate with the 3000, more ability for data to generate and being processed from edge devices all the way to the compute, and then even potentially transferring that data through wireless connectivity. That's kind of where we really see a lot of the diverse industrial applications really functioning. So it's not always exact to what we know, but we definitely see that in a lot of these environments, in a lot of these demands, there's always going to be a lot of edge devices that people are going to be needing to all pull together into one central compute device.
Now, if we shift over to the 6000, right, it's also advertised as being capable of operating and resisting the stressors of harsh industrial environments, and can handle situations where extreme durability is critical. Can you break down what some of those use cases are, where that sort of extreme durability, incredibly harsh industrial environments, where do we see those actually play out, and why is it necessary for an edge computer in an industrial setting, not even in a rugged setting, to be able to resist some of those forces?
I mean, just those forces itself play a detrimental role to any computer. Any little bit of debris or dust or heat or even extreme or any extreme like coldness has a drastic effect on the computer. If a lot of times where the computer itself is already generating a lot of heat, any further heat that's added on there just kind of plays a negative effect on it. You could potentially overheat the device. You can play, or even where if it's too cold to function, it can't even turn on. Or if there's not enough power, the computer itself won't turn on either because it can't draw that power. So all those factors kind of really play a big deciding factor on the 3000, all the way to even the rugged edge, where it's even more harsh, even more extreme, because you have a drastic change in temperature, extreme environments, and there's no way for someone to really go out there and always kind of babysit or monitor the device because it's in a remote location. But when we talk about the industrial edge, it's, it is a bit stripped down. It is a bit more manageable, but it's still demands and considerations that need to be, thought about, because they play a very, very big, heavy role from the 1000, 3000, 6000, because all the computers, essentially, they function, very, very similar. They need certain things to actually make them work. And if anything from a speck of dust causing something to malfunction, it can, cause detrimental downtime for anybody's overall solution.
Another core differentiator for the 6000 that I think is important to highlight is the GPU, right? Looking at the 3 versus the 6000, they share the same motherboard, so same computing power, which is great, right? But the 6000 also leverages a GPU, which means that it is the go-to solution for industrial environments that are going to be high stress, right? Extreme heat, extreme cold, a lot of debris, right? Where it needs to be durable, but also where it needs to process visual data. So we're talking, an edge computer to help support computer vision workflows and operations, right? Or edge AI operations. So Colin, could you get more specific for us on where we see that intersection of GPU need as well as high stress, rugged industrial environments, right? Not even rugged edge, but again, still within the factory floor or the production environment.
So yeah, with the BCO 6000, the GPU really is kind of like its defining feature for the computer. A lot of times, especially with the trends that we kind of see with, artificial intelligence and everything, that's the way, everything that the rugged edge is kind of going towards. PCI expansion, hardware acceleration is really, really key, really important. And to be able to have a semi-rugged industrial computer that allows you to have PCI expansion, that allows you to have robust performance at the industrial edge, not even the rugged edge, like you said, is really, really unique, because you're not going to have a lot of computers that are able to kind of offer that kind of robust semi-rugged performance, and also give you that kind of performance from not only its processor, but now with GPU or even additional, high-speed network cards, or even other additional add-on cards that the BCO 6000 has. And I think it's unique because for us in the overall market, it's one of the few industrial computers of this type of design that's, really out there. So you're not going to see a lot of industrial computers that are made to, meet the demands of a, AI application deployment that isn't going to, offer, an extreme amount of extra bells and whistles that you're going to see in a lot of industrial computers. So that price performance for the BCO 6000 really hits a sweet spot for the industrial edge users who are looking for something that's going to be very, very high in performance, whether through GPU and GPU, but still not going to be pushing the boundaries of the rugged edge.
No, I kind of want to widen the lens here to close things out by looking at security, right? Whether we're talking the 1, the 3, or the 6000, how are these products designed to address security concerns, right? Especially since they're now in environments where they're handling sensitive data. Industrial IoT and the Industry 4.0 revolution is all about creating more data points, and the more edge computers that are capturing those data points means, right, points of access. So I'm curious how y'all approach that, how you have designed these products to keep that in mind, and how they work with an already existing ecosystem of security.
Yes. So with security, there's a lot of points to really consider. And, a part of it is, comes down to not only us, but even just the integrator itself and the overall solution. They kind of have to look at everything from a very agnostic top-down level and see like where those, potential breaches could be. But for us, specifically when we talk about the hardware itself, it's really, one, physically, where are they putting this computer? Is it in a place where it could be accessed easily? If obviously they don't want that. So physically, they're going to have to put this in a secure space. But for the computer itself, Security wise, it's really understanding that, there's going to be potential breaches. There's going to be potential, attacks on a computer some way, shape, or form. And one of the biggest things that for us is that we implement, TPM 2.0 on all of our devices that really allow for the encryption of data to kind of be rooted at that hardware level. So it kind of protects these people, their sensitive data, protects all the, process data that's being collected to be encrypted and not be vulnerable to any type of cybersecurity attacks, any type of actual, hardware root level attacks that people are potentially trying to, get into the computer and try to pull out from. And so all that sensitive data is really kind of, heavily guarded by that TPM 2.0.
All right, Colin, this has been great. We've learned a ton about the BCO series, so thank you so much for placing it within the larger context of the edge continuum, the evolving user edges, and how the BCO series is getting put to work for industrial IoT and the evolutions we're seeing in the Industry 4.0 megatrend here, right, across all industry. Last question here for you is just let's look ahead, right? One of the major trends that is shaping all industry really is the implementation of AI, both very forward-facing as well as back-end AI. And so I'm curious how the BCO series adapts to some of the increasing demands in the era of edge AI, especially in real-time decision-making scenarios, and kind of how the product is designed to be forward-looking, right, and insulate against some of the coming changes as that sector continues to see major evolution as well.
So in terms of future proofing, I think the BCO series really is able to kind of address a lot of what we're going to be seeing, in the upcoming years of edge AI or anything that's going to be coming. Simply because it's the way the BCO series overall is designed. The 1000, as I mentioned previously, it's built around a single port computer, 3.5 inch specifically, that uses that SBC and has an industrial grade chassis around it. The BCO 3000, the BCO 6000 is similar as well, where we take a standardized form factor, the mini ITX motherboard, and we also use that same industrial grade chassis and build around it. So a lot of what the components that really make up the BCO series and make up the overall computer are very standardized. You see them in a lot of different places all over the world. So being able to kind of take those standardized components and build a industrial computer that is using the latest in Intel processing, x86 CPUs, or using the latest in a low profile discrete GPU, and pulling out all the necessary IO that people can have on board, and even adjusting all the storage, data storage for them as well. So it really allows us to kind of move into the future and future proof easily as we kind of scale and as we grow and as the whole overall market, whole overall industry kind of grows into the next level. So being able to kind of take something and be like, hey, as this AI, as AI grows, we're able to kind of go from, for example, this current BCO 1000 to potentially the next BCO 1000, as this whole edge continuum continues to kind of shape and continue to mature.
All right, Colin, I think on that note, we'll go ahead and wrap things up. So thank you so much for your analysis today, for helping break down the BCO series and put it into context for the whole larger shift and trend that we're seeing shaping industrial IoT today, as well as edge computing at large, right? As these different user edges mature, as the edge continuum matures, and as the use cases crystallize. It's great to have y'all's leadership in the industry, really driving things forward and being that company that's helping define those use cases, define the edges, and obviously set the standard on the products as well. So again, folks, we've been chatting with Colin Wu. He's on the product marketing team for Premio, breaking down the BCO 1000, 3000, and 6000. And Colin, if folks want to learn more about the BCO series and how it can be put to work for their needs, right, their specific use cases, where can they learn more?
So if they want to learn more about the BCO series, they can visit our website at premioinc.com. So it's PREMIOINC.com. Our website will have everything they need, from all of our key features down to the nitty-gritty specific specifications for BCO Series.
All right, Colin, that does it. Thanks so much for your time today, and looking forward to chatting again soon in the future.
Thank you.
And thank you everyone for tuning in to today's episode of the Rugged Edge Survival Guide. Again, this is part of a limited series breaking down the Premio product suite and how it fits into the maturing ecosystem of edge computing and the various user edges that are defining edge computing use cases. So make sure that you tune in to the upcoming breakdowns for the rest of the Premio product suite. Make sure you subscribe to the Rugged Edge Survival Guide on Apple Podcasts and Spotify for our future thought leadership and to tap into previous episodes. And make sure you're heading to our website, premioinc.com. Again, premioinc.com, to tap into all of our media resources and learn more about our solutions and services. I'm your host, Daniel Litwin, the voice of B2B, and we'll catch you on the next episode of the Rugged Edge Survival Guide.